Hello students. So let us look at the suggested solutions for the past year paper. So this is from year 2022, 2 years ago. Okay, so the first question over here, they want us to calculate this little expression over here and want us to give our answers correct to 2 decimal places. Well, this is a question to test our ability to use the calculator properly. So if you do that, the solution is 0.14. Okay. Next, they want us to explain whether 391 is a prime number or composite number. Well, what happened is 391, right, is actually equivalent to 17 times 23, right? Therefore, 391 is definitely not prime, it is composite. Okay, and the reason is because it has factors, okay? It has factors. Okay, or rather, let's be more accurate, it has more than 2 factors, right? Including 1, 17, 23, and 391 itself. So it has 4 factors over here, right? So no, it is not a prime, it's a composite, right? Next, given that m and n are whole numbers such that n times n is 29 and m is greater than n, find the value of n minus m. Ooh, lots of things, right? So what happened is we know that since 29 is a prime number, right? So its factors are 1 and 29. Okay, so since m is greater than n, we know that m will be the larger of these 2 numbers, which is 29, and n will be equals to 1, right? Therefore, okay, n minus m will be the same as 1 minus 29, which gives us negative 28, right? Okay, moving on. Well, we have a number line here, and we want to arrange the number line such that these numbers are arranged in ascending order. So let's figure out what they are, right? So what happened is the negative cube root of 125. If we work it out with our calculator, we know that this is actually the same as negative 5, right? So 3 over 7 is fine. This is actually the same as positive 9. Okay, this is actually 7, right? And then negative 3. So with this information, we can actually plot out our number line. The smallest number here is actually negative 5, right? So we go negative 5. Let's label everything, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this will be fine, right? So the first one here, okay, let's mark this one out. This is actually negative the cube root of 125. Okay, next negative, we have a negative 3 over here, right? So negative 3 is here. So this is negative 3. We can label it accordingly. The next number that we will encounter is actually 3 over 7. 3 over 7 is in between 0 and 1, so it will be somewhere here. And then we label it accordingly, right? And then we have 7. But of course, we follow whatever is given in the question. So we put square root of 49 here. And finally, positive 9, this is over here, negative 3 squared. So this is what we get. Okay, so this is your number line. Next, they want us to find the perimeter of a square field where the area is 11664. So to find the perimeter of square field given the area, we need to find the length first, right? So the length, okay, of the square is actually square root of 11664, right? So you work this one out, this is actually 108 meters, right? Therefore, the perimeter will be 4 times 108, and that works out to be 432 meters. Right, next question. Well, next question, it says the temperature at the base of Mount Fuji is negative 1 degrees Celsius. At the halfway mark, it is negative 4. Right, assuming that the temperature decreases uniformly with height, what is the temperature at the top of Mount Fuji? right? So what happened? We have this scenario here. Let me just, imaginary. At the base here, we have -1 degree Celsius. Somewhere in the middle, we have -4 degrees Celsius, right? So what happened is that now they want us to find the temperature at the top. Okay. So what we know is that since it's uniform, this difference here must be the same as this difference here, right? So what is the difference here? Okay, from -1 to -4 is actually 3 units. So from -4 up here, this one must be 3 units. So what we get is actually, I'll change back my pen, right? From -4 degrees Celsius, we want it to be 3 units lesser, 3 degrees Celsius, and that will give us -7 degrees Celsius. So that's the temperature right here, right? -7 degrees Celsius. Okay. Right, part B. Katie took part in a science competition with 20 questions, right? So for every question that's answered correctly, she get 2 marks. But if she answered incorrectly, she was deducted 3 marks. And then if she don't answer the question, 0 marks awarded. So she answered 12 questions correctly and did not answer 5 questions. Show that she obtained -15. So what happened, right? So there are 30 questions in total, right? So the number of questions she answered incorrectly, right? So we have the number of questions answered incorrectly will be equals to, well, 30 questions, which she has 12 correct, so take them away, and she has 5 that she didn't answer. Therefore, she actually answered 13 questions wrongly. Therefore, the number of marks will be equals to, well, 12 questions with 2 marks, right? And then you have 5 questions with no marks, and then she has 13 questions where -3. 3 marks is deducted. So we work this one out. This is actually equals to -15. Shown. Right? Okay, moving on. Question 7. When written as a product or as prime factors, we have 2 numbers A and B. Okay, and they want us to find the cube root of B, right? Leaving the answer in index notation. So the cube root of B is the same as the cube root of 2 to the power 6 times 7 cube, right? So this will be the same as 2 to the power 2 times 7. Okay. Next, they want us to find the greatest whole number that will divide A and B exactly. So what we are trying to find here is actually the HCF. So the HCF, well, you check, right? There's a 2 to the power 6, and then there's no 2 in A, so it's 2 to the power 0, and then you have 5 to the power 0 again, 7 to the power 0 again, 11 power 0 again. They have nothing in common, right? So the HCF here is actually 1, right? So if they have nothing in common, the HCF is actually just 1. Right? Next, question 8. We have 6048. They want us to show either using factor 3 or repeated division that the value of x and y is actually 5 and 3 respectively, right? So just use one of the 2 methods. So I will use repeated division here, right? So you do this. Okay, let's go down. Let's start with 2. Okay, we will get 3024 divided by 2 again. We get 1512. I can continue to divide by 2. This will give us 756. Again, continue to divide by 2. It's still good. So it's even number. We can keep dividing it by 2. 189. Okay, over here, I can't divide by 2 anymore, so we divide by 3. We get 63. Again, divide by 3. We get 21. And then we can continue to divide by 3. Oops, let me write it properly. 7, 7, 1, right? So therefore, 6048 is actually 2 to the power of 1, 2, 3, 4, 5, 5 of them, right? 5 times 3 to the power 3 times 7, right? Therefore, x is equals to 5, y is equals to 3, shown. Okay. Well, Hence, they say use prime factors to explain why 6048 is not a prime number, right? So, sorry, not a perfect square. So, we know the definition for perfect square. In order for a number to be a perfect square, the indices, right, the index of each of the prime numbers should be an even number. Okay, so since the indices, right, indices is actually just the plural for index, okay, of each prime factor is not a multiple of 2, 6048 is not a perfect square. There we go. Okay, next one. Well, the number 6048 m. Now, if we multiply by m, it becomes a perfect square, right? So what happened? 6048 m, right, is actually 2 to the power 5 times 3 to the power 3 times 7 times m. And if this is the perfect square, it's 2 to the power 6, 3 to the power 4, 7 to the power 2. So quick comparison, m is actually 2 times 3 times 7, which gives us 42. Okay, and the next part, p and q are prime numbers. Find the value of p and q such that it's a perfect cube. So now what happened? 6048 times p over q. This is actually the same as 2 to the power 5 times 3 to the power 3 times 7 times p over q, right? So since we want this to be a perfect cube, means we want the indices to be multiples of 3, right? So we want this to be 2 to the power of, well, 5 to the next multiple of 3, we can get 6. 3 to the power 3 is fine, right? And we want to get rid of the 7, right? So it's quite clear. So from here, just by quick comparison, my p is actually equals to 2, my q is actually equals to 7. Okay. Right, next question. Let's zoom in a little bit, right? So over here, they want to evaluate each of these without the use of calculator. So we can do this. So we have 4 to the power 3 plus, well, this will be negative 2 to the power 2 is 4, right? Now 4 to the power 3 is actually 64. When we add a negative number, it's the same as a subtraction. Okay, so the end result is 60. There we go. Next, over here, we have negative 36, right? Minus 6. Now divide is actually the same as the multiplication of the reciprocal, so we can do this. Okay, so negative 36 here. Negative 6 times negative half is actually positive 3. So we have that. And that means the final result is negative 33. Right, next question. At Jurong East Station, the average interval arrival of the train is as follows. So we have a table with the information. Convert each of the following to seconds. So from minutes to seconds, we just need to multiply the minutes with 60, right? So 4 times 60, then 4 times 60 is 240, then you plus 40. Oops. So this will give us 280 seconds, right? 3 minutes is 180. So 4 minutes, 4 times 60, you get 240 plus 12 seconds is 252 seconds. Okay. So the second part of the question, it says, now if all the 3 arrive at the Jurong East Station at 11:07, find the next time they meet together at the same time. So what we are doing here, we are actually trying to find the LCM, right? So let's look at the 3 numbers we are looking at again, the interval. 280, right? If we write it as index notation, it's 2 to the power 3 times 5 times 7. 180 in index notation is 2 to the power 2 times 3 to the power 2 times 5. And 252, write it as index notation, is 2 to the power 2 times 3 to the power 2 times 7. So what we are trying to do here is we are trying to find the LCM, right? So the LCM in this case, for the prime factor 2, we want 2 to the power 3, which is the larger one, right? Times 3 to the power 2 times 5 times 7. That will give us 2520. So 2520, right? 2520 seconds is actually 42 minutes, right? 42 minutes. So what happened? 42 minutes after 11:07 a.m. is 11:49 a.m. There we go. That's your solution. Right? Is that the last question of this paper? Yes, it is. So I hope you have been successful, and all the best for your upcoming test.